call the properties of exponents before we dive into the properties of logarithms. Okay, guys? So just pay attention. X to the 4th times x to the 6th. What do I do with that? Common bases means we combine the exponents, which equals x to the 10th. Good. How about this one? No. It's the same thing. X, if I have common bases, what do I do with the exponents? You add them. Root 6 plus root 6 is not 6. It's 2 root 6. I've got 1 root 6 and another root 6 makes a total of 2 root 6s. Okay, I put that one on there on purpose. Well, all of them are on there on purpose, but I really want you guys to know how to do that. Okay? Don't automatically assume since you've got something times something, right? Okay. Not this one. You subtract, right? So you could either just simplify. I've got 3 a's in the denominator, 3 in the numerator with 1 left over. That's just like subtracting a to the 4 minus 3 and n to the 7 minus 1 equals a n to the 6. Okay? Number 4. So I'm distributing, right? This is power of a power. So 2 cubed, a squared 3 times, and b 3 times. Correct? Let's clean that up a little bit. Which is 8a to the 6th, b cubed. And finally, got this one. I should have equal sign. Yeah, it's a power, right? A power to a power means we multiply. Correct? So, b to the root 6 times root 24, which equals, I'm going to factor it, 6 times 6 times 4, which is actually equal to 6 squared, 2 squared. What gets kicked out? Both of them. So what do I have? B to the 12. Okay, just using properties of exponents, which you have to be solid in because what are logarithms? Exponents. Logarithms are exponents. So don't you think logarithms would have the same properties as exponents do? You ready for that? Okay. What do you think about this? Everybody agrees that 4 times 8 is 32, correct? Couldn't I change, manipulate 4 and 8 to have exponents? 2 squared times 2 to the 2 cubed. Do you follow that? Common bases mean I add the exponent. So I manipulated these numbers and made them so that they both have common bases, so I could add their exponents. So is 32 equal to 2 to the 5th? Okay, so here's my leading into this. Then, if logarithms are exponents, what do you think I could do with log base 2 4 times 8? Okay, so Janelle's saying we should make it 2 squared times 2 cubed. Okay, good. Start from there. Logarithms are exponents, right? This is an exponent, and I'm adding it to this exponent. Isn't that what I'm doing? Adding exponents? We can further take that. Okay. This is all I want to do for now. But we're going to play with this even more. But I just want to make the connection between exponents, logs, exponents, logs. So when we're multiplying logs, we can add the exponents, right? So what do you think I could do with this? There it is. It's that time again. See, I should be glad I'm not in that building. What do I do with this? Oh, he normally has earbuds in, huh? He doesn't normally know this is this is an everyday occurrence. Yeah. Okay, what do we do with this? Subtract, right, Xavier? If it's got the same properties as exponents, then if the quotient property says I can subtract. Well, I'm just giving you the rules, right? We're going to play with them. That's what you're supposed to do. If you see division, you can subtract them. If you see multiplication, you can break them up and add them. Okay? All right, you guys ready? We're going to rewrite all of these right now. I will be able to simplify and evaluate expressions using properties of logarithms. Okay, so before you write anything, I'm going to let you write all this down. Let's just talk about it for a second. So far we've learned log b to the 1 is always 0. The reason for that is, if I were to actually put something like, let's make all the b's 5. Log base b to the 0 power equals what? No. Anything to the 0 power is 1. That's why that works. Okay, log base 5 to the first power is 5. So anything, when these two numbers match, it's 1. That's why. Because 5 to the 1 is 5. 6 to the 1 is 6. 7 to the 1, 7. Okay, which makes this one make sense. Check this out. Change to, so it would be 5 to the x. Okay. But doesn't this make a lot of sense when you look at this? Log 5 to the 5 is 1, so this is log 5 to the 5 is 1, so you've got an exponent left over, and it equals the exponent, because logarithms are exponents, right? Wait, repeat that one. So without that, isn't that 1? So what's left over? An exponent, and logarithms are exponents. That's the way I remember it. Okay, so from yesterday, these are inverses of each other. This is the hardest one to look at. So if you have 5 raised to a log with the same base is the same, then you know that x, these numbers are the same. Okay, we're going to be using all this stuff. Okay, so today, the product property. When we have a product of exponents, we add. So I could break this apart like this. Log b to the m plus log b to the n. Quotient property, what do we do with the quotient? Subtract. So log b to the m minus log b, using 5s again, log b to the n. And here's the power property rule. So if I've got a power up here, a power to the power means what? What do we do? What? Multiply, right? So this means I can pull that p down here and multiply. Saying this log p times. Okay, write those down. The power comes out in front of it, and you're saying, I have this many of them. P. So if I had, if this number was 2,
that's what the power is.
Yeah. Log to a power means you can pull that power in front. So if it was well, it just always works better when you put it in terms of log 5 to 3 times. You can write that as 3 times log 5 2, like that. So copy all that down, and then we're going to play with them. Bing. Okay, so let's work on this together. Pencils down. Let me do number 1. You guys can copy what I do, and then you guys can do letter B. Okay, so it says, it tells me approximately what log base 5 3 is, and log base 5 4 is. So I need to manipulate this logarithm so that it has a log 3 and a log 4. Well, that works kind of nicely because isn't log 5 12? Three times 4. So this is the product property, right? What do we do with the product property? Add plus. Well, that makes it convenient because I know what this is, and I know what this is, so now I can just add them together. 0.6826 plus 0.8614 equals, I have it, let's make sure, 1.5440. So that's what we're doing today. We're manipulating, we're using the properties of logarithms to evaluate. Okay? Questions so far? So I rewrote using properties, I substituted, I evaluated. Questions? Okay, so copy that one down and then do the next one, which is going to take a little bit more thought. Somebody said in the last class, why do you always give us the hard ones? It's not that I'm giving you the hard ones, I'm trying to make you think. Record. Okay, so I already started it. Log 5, 4 times 25 is 100. This is the product property. We can split it up and add them, which is really 5 squared, right? So isn't 5 to the 1 is 5, right? So this right here is 1. Remember? What does the power do to it? What do we do with that? That's the power of a power, right? What do you do with the power of power? Multiply. I already know what log 5 4 is. What is that? 0.8614, correct? I already know that. This is 1, but I need to put that 2 out in front, right? Two of these. And what is one of these? 1. So what is 2 times 1? 2. Okay, I don't want to go too fast. Does everybody follow me so far? So I broke them apart using the product property. I substituted. Then the power property means I can pull that 2 out in front. So it says 2 log 5 5. Well, log 5 5 is 1, so this is really plus 2 times 1, or just 2, which equals 2.8614. So the key is to try and find the base that you need with the exponents, right? Try and find patterns. Can I go? Not yet? Okay, you guys ready to try another one? Okay, pencils down, let me do this one. How could I change 0.75 to be something friendlier? Make it into a fraction, which would be 3/4, which is very nice and convenient. Why? Because I know 3 and I know 4, and what is the quotient property? Subtract them. So this would be which equals, what's this one? 0.6826 minus 0.8614, which equals negative 0.1788. Questions? You guys ready to do one on your own? Okay, try that one. All right, so I would start by saying log 581 minus, that works well right there, right? What is this? 1. What's this? That doesn't help me out yet. Okay, we could also, let's go nice and slow. Isn't it 9 squared minus 1, which equals 3 squared 2 times minus 1, which equals 3 to the 4th minus 1, which works well because I know what log 5/3 is, right? And how many of them do I have? 4 of them. So I would say 4 log base 5/3 minus 1, which equals, what is log 5? There it is, 0.6826 minus 1, and I'll give you your answer right here. It is 1.7304. Questions? No. If you can see that that's 3 to the 4th from the very beginning, then great. You don't have, I'm just going nice and slow so everybody can follow exactly what I'm doing. What? No. You've got to practice manipulating these powers. That way you can be successful at trying to find the pattern.
That's what I originally done this, but
You've got to be able to do it without your calculator. Okay? All right, questions? All right, that's all I have for you. So let's go over our, I want you to pay attention. Okay, Matt. What did you learn today? Properties of logarithms. What are the 3 properties? Product, quotient, power. Good. On your assignment sheet, how could you use properties of logarithms to solve the following? What do you guys think? Look at it. We didn't do this today. This is what we're going to do on Monday. How could you use what we did today? The bases are the same, okay? Bases are the same. What does that mean I can do with these? They're being added. Think the inverse of what we did today. Good, Janelle. These, if I add them, isn't that the same as this? Now that I have this one and this one, these are the same, right? That means they're equal to each other. Exactly. So that would be 8x equals 24. So what does x equal? 3. That's what we're going to do on Monday. Okay? Good job, guys.